Okay, so here is a topic that is going to be on the AP exam, and this topic is about slope fields. Now, only the simple type questions will be on the diploma, and we know that when we take the derivative, we can get the slope at any point. So here's a question where they say that the derivative is d, or dy over dx, is x. That's the derivative. Okay, so how do we do our slope fields? Well, first of all, we need to pick x values, and then our dy over dx also equals x in this case. So maybe this example is so simple that it might be confusing, but it's the simplest one there is just x. So if x is -4, well, the slope is -4. Well, let's kind of figure out what's going on right now. So let's first of all get our numbers down. So we have 1, 2, 3, 4, 1, -1, -2, -3, -4. Okay, so that's 1, 2, 3, and 4. -1, -2, -3, -4. And then 1, 2, 3, 4. -1, -2, -3, -4. -2, -3, -4, and 1, 2, 3, and 4. So the first one, -4, the slope would be 4, or -4, sorry. Because if I put that x value into there, that's what I get. If I put -3 into there will give you -3. If you put -2 in, you get -2. Put -1 into your formula, that's -1. If you put 0 in, you'll get 0. Okay, and the same thing, if you put 1, you'll get 1. If you put in 2 into here, you will get 2. If you put 3 into there, you'll get 3. And if you put 4 in there, you'll get 4. Now, when you do slope fields, easy ones are 0 and 1, and -1. Okay? Now 0 is just a flat slope like that. Okay? Your -1 will be going down at like a 45-degree angle. And your 1 will be going up at a 45-degree angle. And these are going to get steeper as you go. That one wasn't very much steeper. Okay, and same thing with these. They're going to get a little bit steeper, a little bit steeper, and a little bit steeper. So when x is 0, it says all of the slopes are 0. Okay, so at x equals 0, we got that. So when x equals 0, all of my slopes are 0. Now this one's so easy that what I'm going to do is just do them down in a line. So the slope will be the same vertically on this one, right? The next one will give you more of a clear idea that what if it just wasn't that simple. Okay, when x is 1, the slope will be 1 wherever you go. Okay, so there it'll be 1, and there it'll be 1. It'll be 1 anytime that you see, and it'll be -1 through when x is -1. Okay, so at every y value, we're just going to put. Okay, now at 2, slope is 2, so it's just going to be a little bit steeper than the last one. Oops, and it's tough, right, to just eye this, right? You don't want to be too steep because we still got 2 more slopes to do. Okay. And then at 3, the slope's even got to be a bit more. And at 4, it's like almost going to be like straight up and down, right? Like slope of 4 is pretty steep. So it's hard, but you just kind of want to show your slopes are getting a little bit steeper the more you go right. And don't be like me, you actually want to try and like line them up. As you can see, I wasn't doing a very good job there because they should all stay. Okay, now I'm just do the other side. So negative 2 has got a slope of negative 2, right? So again, a little bit more of a slope than the last one, right? We want to make sure that we're going nice vertical. Okay, that at negative 3, we're going to be a little bit more vertical. Okay, and then 4, we're going to be a lot more, or we're going to be more vertical than that one even. Okay, and that's how you do your slope fields. And you can actually see kind of a pattern going. So, oh, I missed. There should be a slope there of 0, right? And if you kind of follow this through, you'll get a slope, or it'll kind of follow like a little bit of a pattern here. Where's my first one? Yeah, we'll just kind of go, you know, maybe like this, right? And then this one will go kind of like that. So it's showing you your slopes at every point on the graph, and which gives it kind of way that this might be a parabola, which when we do later, if you do the integral of x, of the slope x, right? So dy over dx equals x. If I did the slope of it, if I did the integral of my slope, I should get back my original equation. So that would be 1/2 x squared plus c. So you see that that's a parabola, 1/2 x squared. And again, this is kind of a simple question, but as you can kind of see, right, the slope fields are, you know, just kind of doing that. So you can see that that's just a parabola. Okay, let's try a little bit harder one, but not that much harder. And then I have examples or questions for you to do, and I've got all the solutions for you to practice. Okay, so this one's different because it has dy over dx equals negative 1/2 xy. So we want to start picking points. You can see that the chart that I've done on the side is much more elaborate. So we've got our x and we've got our y's. And then we've got our dy over dx equals negative 1/2 xy. This is our slope. So when x equals 0 and the y equals 0, if we put zeros in here and here, do you see that we will get an answer of 0? So at 0, 0, which is right here, we would get a slope of 0. Now let's put some numbers in here. I'm just going to go up to actually 2 on there. So the 0, 1, I'm going to split this up a bit. So 1, 2, negative 1, negative 2, negative 1, negative 2, or positive 1, positive 2. Okay, now do you notice that if x is 0, anytime x is 0, do you see that the slope would be 0? Like anytime if you took this and put it in here, it doesn't matter what y is. So if x is 0, we will get slopes of 0 all the way up and all the way down. Now also, what if y was 0? So if y was 0, then no matter what x is, I would still get a slope of 0. So, and I'm actually going to show you that in more detail, but some students will see that right off the bat, that if 1 is 0, then the slopes will be 0 when x is 0, and the slopes will be 0 when y equals 0. Okay, so let's do when x is 1. Okay, we've got to keep this straight. So when x is 1, and then I'm going to go through all my y's. Let's start from the very bottom up. So negative 2. Okay, so we put 1 times negative 2 is negative 2 times a half, times a negative half, I should say, is 1. And remember, that's our 45-degree angle. Okay, what about if I put 1, negative 1? I will get 1/2. If I put in 1, 0, I get 0. And I've already graphed that one. If I put in 1, 1, I will get negative 1/2. And if I put in 1, 2, 1 times 2 is 2, times negative 1/2 is negative 1. And remember, that's also a 45-degree angle going down. Okay, so when x is 1, okay, starting at negative 2, I will get a 45-degree angle here. Let's do them in red. So this is 1, negative 2. I get a 45 there. Then I get a little steeper. No, sorry, half. Right? So it's going to be a little bit more shallow or horizontal. And then if I keep going up, I get negative 1/2 and then negative 1. Okay, so my next one I'm going to do is negative 1. So let's do negative 1, 2. Right, and if I put that in, I'll get the answer negative 1. If I go negative 1, oh, that should have been negative 2. Sorry, negative 1, negative 2. Negative 1, negative 1 will give me negative 1/2. Negative 1, 0, which I've already graphed, will give me 0. If I put in negative 1, 1, I'll get 1/2. If I put in negative 1, 2, I'll get 1. Okay, so I've done all my negative 1s. So negative 1, 2 is negative 1, which is a 45, remember? And that's also going to be a 45 degree, and that's horizontal. Okay, that's also horizontal. So a negative 45 might be right like that, and then negative 1/2 is going to be a little bit shallower. Okay, and then I got 1/2, and then I got 1. Okay, you can see that there's kind of a mirror image going on opposite sides of the y. Okay, now you can see these do take a long time. Now we're going to do 2's. So on my 2's, I'm going to go negative 2. 2 times negative 2 is negative 4. Times negative 1/2 is 2. Actually, I'm going to switch colors here just so you can see I've started a new. So let's go 2, negative 2 times negative 1/2 will give me 2, because that's negative 4 times negative 1/2. And then I'm going to go 2 times negative 1 times 1. 2 times 0 is 0. I've already done that one. And then 2 times 1 is 2 times a negative 1/2. Okay, I should have negative 1 there. And then 2 times 2 times negative, it's negative 2. I think I have that written in my book wrong, so I got to change that. Okay, so let's do this. At 2, negative 2, okay, I have a slope of 2, so it's a little steeper than that last one. Okay, and then I got my 45 next, right? At 1. Okay, then I'm at 0. Then I'm at negative 45 degrees, and then negative 2, so even steeper yet. Okay. Now, let's do my negative 2's. 2, negative 2, negative 2, negative 2, negative 1, 0, 1, 2. So negative 2 times negative 2 is positive 4 times a half. That's negative 2. Okay, this will be negative 1. That's 0. Okay, this is going to be a positive 1, and this will be a positive 2. Okay, so back to my graph here. At negative 2, I will have a sharper negative 2. Then I will have a negative 45, then 0, then 1, then 2. Okay, nice sharp. So here's my slope field graph. And, you know, just kind of stepping back, you could sort of maybe see it, but, you know, this one is kind of coming along here, and coming over and down. Maybe it's, this one's coming here, you know, and down. Okay. Also here and down. Okay, oops. So, not as concerned about the, you know, drawing in the approximations, direction. Those are called directional fields when I put them in, but they're just approximations. But what's more important is that you can graph the slope fields. Okay, so here's the 5 that I want you to try now, and I have provided you with all the solutions to those, so you can check them out on my website if you need to. So hopefully you can see all those if you do not have your pages on you, and then you can go and check them on my website. I have all the answers up.